Here. Okay, Bismillahir Rahmanir Rahim. So to find a discharge rate from a hand pump, it can be calculated in a very easy way. For example, if you have a hand pump and it is discharging water, so you can calculate it by just keeping a bucket below it and take a stopwatch, and you know the volume of a bucket, and by using the stopwatch, note the time, that how much time it takes to fill. So note that time, and after uh, noting that time, so we can calculate it by the volume by time, the discharge rate of a hand pump. So you should also note the average working hours per day. So if you haven't any data about that, so you can assume a 6 hours of a working hours per day. Based on these two values, you can calculate the per day availability water and number of functional days in year. So for example, in a summer, if the water goes down, so it may be not functional in summer, so the number of days may be subtracted from the 365 days. So based on these days, multiply with the per day availability, we can calculate the total water availability throughout the year. And the discharge rate, if not available, you can assume 12 liters per minute or 720 liters per hour if the data is not available. Similarly, the water availability from a tube well can be calculated in such a way that the discharge rate of water cannot be calculated by buckets by simple method, because the pressure is very high. So we cannot use that method. So the flow meter is basically used to measure the discharge rate of water from a tube well. So the average hours of pumping in a day, the total availability can be calculated, the hour pumping a day and the discharge rate per liters per hour, and the total availability per day can be calculated by multiplying these two columns. And after that, we can calculate the average number of day availability in a year. So water availability in a year can be calculated just by multiplying the number of days the water is available in a tube well or bore well. So from a open well be calculated in such a way that just counting a number of people extracting daily the water from a well and how much water each person is extracting. So you can count the number of buckets just and taking the average of that. And by multiplying these two columns, we can get the total water extracted in each day. So based on that, the average number of day of water availability in a year, and based on the availability of the days water availability number of days, we can calculate the water availability in a year. So now if you know about the water availability and the demand, so based on that you can calculate the water gap throughout the year. So based on that gap, you have to decide that how much hand pumps should be provided, what type of water supply system, or whether the continuous or intermittent water supply system should be provided, should be it the loop system or a branch system or a gravity system, should be it a pump system. So based on this gap, you have to provide a water supply system. So basically the above all calculation are basically if you want to extend the existing water supply system. If you want to design a water supply system for a city which are going to design or recently constructing in the near future, so for that purpose you don't need to calculate these calculations, but the water availability should be determined from these different sources in the vicinity of that community located at the side of that community or a city or a village constructing in a near future. So based on that gap, you can calculate the number of household tap connections, number of stand posts, number of hand pump, required pipeline, main, sub-main branch. So so by using that gap, you can easily calculate these parameters for a water supply system. So basics of calculating roof water harvesting, mostly roof the top rainwater harvesting, simple method to collect store rainwater from rooftop. So for example, if we have a house, right, a 3D. So we know the area of a roof and the intensity of rainfall can be calculated from the meteorological department. We can get value from there, and by the using the runoff coefficient, mostly the for example, if the roof of a house is constructed by a concrete, so we can use the runoff coefficient of about 0.9, 0.8, and we can just plug and chug in this equation. So the discharge from each roof can be calculated. So if the water falls on this area, it is collected, the slope is provided to it and collected through gutter pipes, and then it can connected to the conveyance pipe to flow up to the filter, where the sand filter or rapid sand filter, slow sand filter are provided, and after that it is stored in a storage tank, a ground storage tank, and then it can be used for different purposes by drying through from a underground tank by a pump, and use it for a different purposes. So this is just an example to calculate the discharge from a roof. So for example, if you know the area of a roof, the runoff coefficient, and 0.8 meter depth of a rainfall throughout the year, so we can calculate the how much rainfall we can calculate. So based on this value, we can design the storage tank for storage of that water collecting for the roof. So I think that's enough for today. So we will start from pipe distribution record in the next lecture. So if you have any questions, you can ask. So what concept? Any question? Khalid Bhai? Elizabeth?
No, sir.
आवाज हमने राजी so what concept?
सर स्टडी को फिलहाल नन को पकड़े से ग्रांड नो
जी
स्टडी को कुछ बतून कुछ बता तो
सही शो जी मेहरबानी
Bashir Seva,
जी
زما یو کوېسچن دی.
जी
هغه دا دی چې ګریویټي بیس سیستم چې موږ کوم ډیزاین کوو او
جی.
پمپینګ سیستم چې موږ کوم ډیزاین کوو،
जी
د دې دواړو په ډیزاین کې چې کوم فیکټرز موږ اخلو، هغه چې کوم دی هغې دواړو کې لکه څه سیملیرټي شته او که نه سیم فیکټرز موږ لکه کنسیډر کوو ډیزاینینګ کې.
देखिए बस मेन फैक्टर دا دی چې لکه دی کې لکه ګریویټي سیستم کې موږ سره دی چې موږ سره سورس په سم هایټ باندې پهله نه موجود وي او موږ سره پمپینګ سیستم نه وي پکار سمپل پایپس کنیکټ کو or without any energy we get that water from through gravity system, but while in a pump system we provide for pumps and electricity, so that's the main difference in between these two.
صحیح لکه ګریویټي سیستم کې موږ چې کوم سورس دی لکه هغه سپرینګ کېدی شي که نه سپیسیفیکلی هیل ایریاز کې نارتن ایریاز کې
بالکل هم northern areas کې mostly in SWAT areas they are providing a gravity system.
موږ دلته سیملرلی دلته کوو لګیو که نه ګریویټي بیس سیستم موږ سره شته دی نو
بالکل
موږ فیچر ته لګیو په ډیزاینینګ کوو نو ماش داسې څه سیملیرټي شته دواړو کې چې موږ به هغې کې اخلو که نه مطلب دغه فیکټر دی پکې مین.
But based on the demand, based on the junction demand, you have just to calculate the pipe diameters and the length of the pipes, and then that's it, which is mostly similar in both of these systems. Just the difference between that in a gravity system we do not provide a pump, and the pumping provide a pump and electricity, or using a diesel pump to fulfill the demand of any water supply system.
Oh, how about the terminal pressure?
What terminal pressure?
I mean the terminal pressure, will you be discussing in
Yeah,
the design?
inshallah we will be discussing like a consequent lecture. Basically the minimum when we discuss the standards, Pakistan standards, then we will discuss there that what are the minimum pressure should be provided at the junction and what are the maximum provided pressure that should be provided at junction. So mostly about 20 psi is the minimum pressure and 80 psi is the maximum pressure provided at the junction.
Right.
Any other question, Wilkins?
زما یو کوېسچن دی
जी जी
دا تاسو لکه وویل څه کله الیویټډ ټینکس وي اخته مو ډسچارج ورکو پمپ په ترو باندې نو د دې ډایا د دې پایپ ډایا کوم دی دا به بیا ډیفرنٹ فارمولې سره به ډیزاین کیږي لکه ګریویټي خو به خپل یو ډیزاین پیرامیټرز بي خو د پمپ په ترو څه کله زه فیډ کوم نو د دې بیا ډایا د دې لکه تاسو ما ګایډ کو ور باندې
depending on the demand. So we decide that what volume of elevated storage tank is provided in a system. So rising man, so based on that capacity, we supply the water through rising man to the storage tank, and we will select based in the trial and error method that which type of dia should be sufficient for a proper supply of water to that storage tank to minimize the losses through that pipe. So it depends on the condition. It's not a specific value that we will provide a 6-inch dia or a 1 feet dia. Any other question? Okay, thank you. Assalamu alaikum.
Walaikum.
وعلیکم السلام